So anytime we're solving inequalities, equations, whatever it might be, simplifying both sides before you start moving things around makes your work much nicer. Ken, there's a lot of you when I've graded different things that we're not simplifying before we start moving things around. Remember, to simplify means that we're going to distribute, bless you. So negative 10x and negative 10 times negative 7 is a positive 70. Then I guess I'll get one side to be 0, so I'll add 10. So 0 equals negative 10x plus 80. And then I can minus 80. So negative 80 equals negative 10x. Divided by negative 10. Negative x is a positive 8. With all inequalities, after we find that value, that's our anchor point. This is an open circle because of it being just less than and not less than or equal to. For the shading, again, we need to test the value. And it seems like we're getting much better with this, understanding what happens after we test. So testing x equals 0, I get that negative 10 is less than negative 10 times 0 minus 7. So that's times negative 7, which is 70. So negative 10 is at less than 70. It sure is. That's true. Since it's true, that means we're going to shade towards the side that has 0, which is to the left. And all values that are less than 8. So in interval notation, it's an open parenthesis. Always an open parenthesis on infinity because we'll never get to that specific value. And then the rightmost value is 8, or the biggest value is 8. With it being an open circle, again, we just use a regular parenthesis. Okay, again, when it's filled in, that's the only time you're going to use a squared bracket. Okay, then adding on to the second part here, I'm going to go ahead and add 1 to start to get the right side to be 0. And when that happens, the negative 1s and 1s go away. So I get b divided by 2 equals 0. Multiply by 2. And I get b equals 0. So 0 is our anchor point here. That is an open circle once again. And with our anchor point being 0, we can't test 0. So we've got to pick any other number to test. And you can always pick whatever you want. Doesn't always need to be 0. I would pick a number that is divisible by 2, so any even number. I'm going to pick 10, so test x equals 10. So 10 divided by 2 minus 1, is that greater than negative 1? So 5 minus 1, which is 4. Is 4 greater than negative 1? It sure is. That's also true, which is off to the right here. And then our inequality, or our interval notation, this is 0. And then the furthest right it goes to is positive infinity. Everything has a regular parenthesis there. Put that away. Bell thing. Yeah, Nathan, what you got? What's that? For this? Well, if you add 1 to both sides, negative 1 plus 1 is 0. Okay, good point. So this is another mistake that some of you are making. If you multiply by 2, that's fine, but that negative 1 also gets multiplied by 2, and that's a mistake that a lot of you have been making, which is why typically when I'm solving equations, the multiplying or dividing step when I'm trying to get the variable by itself is the last thing that I do because so many of us forget about this. So if you want to start by multiplying by 2, there's nothing wrong about it. It's just that every single thing needs to get multiplied by 2. And that's where a lot of us are forgetting. Okay, so even with that, you would still get 0 there. Okay, Nathan, thanks for bringing that up. That was a common mistake on the previous test. I haven't looked at your quizzes quite yet, but that does happen quite often. Okay, so the whole point of what we're doing today is we're going to take 2 inequalities and we're going to put it on one number line. This does not work out the way that we wanted it to unless these signs were flipped. That's what I'm saying. Like, I should have had you all change that before you started. So for this, it doesn't work out all that great in the sense of kind of looking at what we're covering today. So let's just skip the next part. We don't need to do this. But basically, we're going to combine them and put them on one number line. Right now, if we put them on one number line, it's not going to work out the way that most OR inequalities, which that's what we're working on today, work out. So we'll just skip this one for now because we'll catch that when we actually get to the examples here. So today we're solving OR inequalities. The word OR will always be present when solving an OR inequality. And it's just two inequalities in one. That's really the only difference here. It is helpful if we understand what the word OR means, right? So a lot of us probably, like, we know what that word means, but don't think about it all that often. I like to explain it with just like your parents assigning chores to you. So if your parents said, take out the trash, or clean your room, based on the word or, are they expecting you to do both of those things? It depends on your parents probably, right? Like if my mom says do the one or the other, she's probably expecting me to do both. But if I'm going by her definition of or, really technically that just means one or the other. Okay, we don't necessarily need to do both. So with an OR inequality, we're going to graph the solutions that makes one of the inequality true and the other one and the solution that makes the other inequality true. We're graphing numbers that make one inequality true or the other true or both. Okay, so you can do both, but you technically don't need to. The flip side of that is if we change the or to now and that's what we're going to work on tomorrow, now your parents are expecting you to do both of them, right? If they say take out the trash and clean your room, they're expecting you to do both of those things. Okay, so just paying attention to that subtle difference between the words or and can help us when we're starting to solve these inequalities. Okay, so like I said, every time you're solving an OR inequality, we're going to have that word OR present. And what we'll go ahead and do is we'll do 3 and 4 together, maybe have you all do 5 and 6 on your own, and then assign 2 of the problems to get you all up to the boards from there. So really, we're treating it like 2 problems, just like the opener. So a divided by 8 is less than -1, so I'm going to go ahead and just multiply by 8. And that gives me that a equals -8, and there's an anchor point. That anchor point at -8 has an open circle, and we need to figure out where to shade. So I'm going to test a equals 0. So I get 0 divided by 8 is less than -1. So 0 less than -1, that is false, right? That is not true. So shading the side that has 0 would make this false, and thus we want to shade away from 0, which is to the left. Writing the inequality for that number line is that it goes all the way to the left to -infinity, and the furthest or biggest value that it gets to is this -8. So -infinity to -8, all open parentheses so far. All right, then for our second inequality, in this case, I'll skip the getting one side to be 0 and just make it go a little bit faster by subtracting 8. So I get a equals 6 minus 8, which is -2. And so we're going to put that on the same number line with an open circle. And once again, we need to figure out where to shade. Are we going to shade towards 0 or away from 0? So I test a equals 0. So 0 plus 8, is that greater than 6? 8 being greater than 6, that is true. Since it's true, that means for this particular anchor point, we want to shade the side that has 0, which is the side to the right, or the values that are greater than. And so you can see on the same number line, we're shading most numbers, right? The only numbers that are not included in our number line where we're shading are values in between -8 and -2. So an OR inequality is going to have more solutions than, say, just a regular inequality, or for what you do tomorrow, an AND inequality. So now we'll write this, what this number line is representing in interval notation, and that's all values from -2 to infinity. Now, one notational thing that is going to be new for us to add into this is when we have a compound inequality or an OR, we use this U It's not the letter U, but it looks like U. And this is what groups them together, saying that our values that make this inequality true are all numbers from negative infinity to negative 8, as well as the numbers from negative 2 to infinity. So this symbol, this U, is called the union symbol. And it's used for OR inequalities. Okay. So you can almost think about it as like our solutions are negative infinity to negative 8, or the numbers from negative 2 to infinity. So you can almost replace it with the word OR. Okay, let's do one more together. In fact, why don't we do one on, let's do a little more complicated one. 4, I'll have you all do on your own here in a second. Let's do 5 together. Okay, so with 5, again, we solve each inequality separately. Again, I'm okay if you want to keep getting one side to be 0, that's perfectly okay. I'm going to start moving away from that. It just saves us one step, especially some of these equations that get a little bit longer. So negative 10v, then that equals 70 minus 10 is 60. Then divide by negative 10. And get that v equals negative 6. This now this is a closed circle because of the or equals to. And we want to figure out which side to shade. So let's test v equals 0. So negative 10 times 0 plus 10. Is that greater than or equal to 70? Well, the negative 10 times 0 is 0. 0 plus 10 is 10. So 10, is it greater than or equal to 70? That's false. Since that is not true, that means we want to shade the side opposite of 0, which are all the values less than negative 6. So this number line in interval notation is showing all values from negative infinity to negative 6. And this time, we use a squared bracket on the negative 6, saying that we're going to include that value as a number that makes these inequalities true. Now we'll do the same thing over here on the other number line, or on the other inequality. So I'm going to subtract 9. And so that gives us 4v equals negative 20. And divide by 4 and get that v equals negative 5. Negative 5 has an open circle. And now again, we just need to figure out where to shade. So testing v equals 0, just like we've been doing, gives us 9 plus 4 times 0. Is that greater than negative 11? So 0, is that greater than negative 11? That is true. Since that's true, that means I want to shade towards 0, which are all values to the right. And so this particular part of our number line is showing all values from negative 5 to infinity. So negative 5 to infinity. And then again, when we have these multiple or compound inequalities, the way that we're going to write it is using that union symbol. So the number line with the interval notation represents our solutions. And again, right, this means almost every number makes these inequalities true. The only numbers that don't work are any number between negative 6 and negative 5. Okay, and negative 5 itself does not make this inequality true as well. But most numbers work in this case. Okay, on your own, I want you to work through problems 4 and 6. We'll check those, and then we're going to pick 2 more problems for you all to come up and show on the whiteboard before we get you working on homework. All right, I'll give you like 5 minutes to work through those problems. Again, I need you to try them. Do not just sit there and wait for me. Give a valid attempt at working through them. Okay, so all I got to do on number 4 on the left inequality, is subtract 6. That gives you your anchor point at 4. It is an open circle. Statement, so I want to shade away from 0. So I am shading the greater than sign there, so that part of that inequality is 4 to infinity. Again, no regular parentheses on all those values. Then negative 3x greater than or equal to 3. Divide everything by negative 3. So that gives me x equals negative 1. That is a closed circle because of the or equal to. So closed circle at negative 1. And when I test, I get another false statement. So once again, I'm shading away from 0. That part of the number line is showing all values from negative infinity to negative 1, but this time we're including negative 1. So negative 1 has that squared bracket. And again, as of now, the only time we're going to use that is if it is a filled in circle. Okay. The last one, which just has a couple more steps for you to solve and get it by itself, but not any different. So again, if you want to subtract 30 and get one side to be 0 like what we've been doing, that's absolutely okay. It's a little bit quicker if we just subtract 6 and get 3x equals 24, so x is 8. 8 is going to have an open circle because of it being just greater than. And this time when I test 0, I get that 6 is greater than 30, which is false. So just like before, I'm shading this away from 0, which is off to the right there. And then the second part, subtracting 5 to get 2x equals negative 2. And divide by 2, I get negative 1 for my anchor point. This one has a closed circle. And then testing 0. Once again, I'm left with 5 being less than or equal to 3, which is false. So I want to shade away from 0, which are all values to the left. Question, what you got?
Will those two lines ever cross each other?
What is Hunter observing here? What do we notice about where we end up shading all the time? I would say shading away is how I describe that. Okay, in this class, 99% of the time, when you see the word or, you will shade away from the anchor points. It is still worth testing because there are exceptions. Okay, there are exceptions to this. But like I said, 99% of the time, after finding your anchor points, you do end up shading away. So that at least should give you an idea as to what to expect when you are testing and figure out how to shade. Okay, so with or inequalities, Hunter, that is something that you're exactly right about. Okay, let's do 8 and 10. We'll skip the odd number problems, so 7 and 9 we won't do. We'll do 8 and 10. Again, I'm going to come around and assign a problem to your group. Send somebody new up to the board who has not been up before. And we're going to do 8 on this side, 10 on the other side. Either way, start working on both of them right now. All right, for everyone watching the video, you can go ahead and check your work here. Seeing what I get for the anchor points, then the shading, and then also what the inequality is, or the interval notation representing the number lines. So go ahead and check everything. And once you're all done, that's it for today. You can go ahead and start on your homework. Have a great day.